Hi, thank you for joining this afternoon. Today we're going to discuss some very exciting new ways to create and profit from iOS malware. My name is Khilik Tamir. But before we jumped in, a word of warning, this talk is going to be focused on a non-jailbroken iOS device. So if you're here looking for a sandbox escape or the latest jailbreak, this is not your talk. You can take your time and enjoy it in other tracks. A bit about myself. I'm a security researcher based in Israel. Released the Analyzer pen testing framework for iOS application, Bell, Chapuse, and other tools for pen testing. I am a security trainer. Did the iOS hacking and Black Hat consecutive on 2013 and 2014. I gave security talks, and I'm a Twitter addict, so you can look me up at Twitter. So let's go over the overview of the talk. First, I'm going to represent the basics of Apple's application sandbox. Why is it important and how it's built by, and the rules that it must follow. Then we'll talk about evil client creation and the latest and greatest in evil client exploitation on a non-jailbroken iOS device. Then we're going to talk on new vulnerability or reintroduced vulnerability, exploiting evil clients. Then we do some demo, if demo gods are good with us. And we'll talk about mitigation and detections and have a Q&A. So here is a question to ponder during this talk. FBI had allegedly paid $1.2 million to get into a locked device. A device that was set up with a brute force mitigation to wipe all of its content, had per the rumors passcode of simple passcode, 4 characters. How much would an adversary pay to gain access not to the device but to an encrypted content inside an application? So when you picture a device and you have on your iOS device, you have a password manager, you have this secret chat application, and when the application developers are security minded, they keep data secured. They want their content to be encrypted. So think about someone gaining access to a device and want to go into and take down this, or decrypt the messages or decrypt the content. How much would they pay in order for that to achieve? And keep in mind that the vendor can always say, we have implemented self-encryption, we don't have the keys. So don't come us with banging questions or subpoenas because we don't have the keys to decrypt the data. It's on the device itself, right? So in this talk, we're going to tackle this question by exploiting the possibilities of utilizing evil clients to gain access to a security container like that. We're going to talk about the latest iOS state of evil clients and malware creation, utilizing Apple's Homebrew Certificate program. So let's start at the beginning. The application sandbox. So on any iOS device, each application has its own little playground, the own little sandbox, when it keeps all of its content in place. And it must follow the sandbox rules laid by Apple operating system, iOS. Each application has its own ecosystem, its own file system, and one application must not cross the border and access other application file system contents. File system is mapped by utilizing the bundle ID identifier during installation process into that specific application. And if by any chance other application tries to access that security container which is not owned by it, is going to get an exception from the process, going to say you try to access a sandbox which is not allowed by your application. When looking at application sandbox contents, we most often see SQLite databases for storage, application files, configuration files, and a lot of them hold and contain sensitive information. By the way, WhatsApp all-in-all encryption doesn't work on the device itself. On the device itself, the database is decrypted. It's not encrypted. So if a malicious application can take hold of that content, it could read all of your chat messages from WhatsApp. Another example is application-generated preferences file that holds all kind of mysterious and sensitive information. Passcodes, remote servers, VPN credentials, etc. Not always these content is stored protectedly. Sometimes developers are trusting iOS in doing what they think is iOS job by protecting these credentials. And we'll see that that's a misbelief that can be exploited. Another example of application sandbox content is the application-generated cookies. So whenever you open up an internal web page from an internal application, all of your cookies are stored for that specific application inside of the application sandbox, which means if you have authorization cookies, such as session cookies for Facebook, they are stored unencrypted on your device. Any process, any malicious process that gains access to these cookies can hijack your session and steal your account. So, when summarizing the basics of application sandbox, we understand that application sandbox contents are one-of-a-kind ecosystem for each application, which iOS by default protects with a high level of security for not allowing other processes to cross that boundary. By crossing the boundary between applications, sensitive information can be abused and exploited by malicious processes. And when we speak on malicious processes, let us have this information in mind and talk about iOS malware. So, when looking at iOS malware, in order for getting a sample running on a device itself, it must somehow miraculously end itself on that device. It didn't came like that from the Apple Store, right? And in order to get that piece of malware on that specific device, that code, that malware, must have been following Apple's rules. And Apple rules for any code, malware or not, are the following. All code running on an iOS device, this is like the 10th commandment, but all code running on an iOS device must be signed by a certificate that is provided by Apple. All apps that are submitted to Apple must go a very, very selective, I'll say, that's the right word, selective review process, application review process, which may take a swift amount of time or a large amount of time. It can get you banned or rejected for hosting your application inside Apple Store. All certificate applications must be identified. In order to get a developer certificate, you must supply Apple with identification means of who you are, if you're a company, all of your legal documents. And Apple has the possibility to request more and more identification if it feels that something is not right with your application for developer certificates. All installations of any source of application is going to be validated once it's installed. And that's a new mitigation that Apple has introduced in iOS 9 to mitigate against malicious distributor certificates that were abused in order to create all-in-all malware installation from remote. So if you want to install an application on a device, you have to go through these rules. Needless to say that any misbehaving application will be removed. Any misbehaving developer will be targeted with actions. And every installation requires to be signed by these certificates. So the certificate is a big deal. It's a big deal. It's one of the main mechanisms Apple had kept its garden protected. By requiring any developer to supply identification means that you can create any code you wish, but once Apple has found about it and discovered it, it's going to cost you with attribution. Your app might be pulled out, you might be targeted by legal, whatever Apple feels like, which we came to learn just in the past 2 weeks, right? So if you're aware or not aware, Stefan's application has been removed from the App Store because Apple had claimed it violated private APIs. Now that's a debate that can be pondered, but there's a live demonstration of Apple's reusing that attribution against whoever they feel is breaking the rules. When you look at more classical example, you can see that applications, malicious applications, were hosted on the App Store, such as a Zurich Helper and the Xcode Ghost. It was infecting iOS builds, shipping to Apple, passing app review, being hosted on the App Store, and were very good articulated by Klaus Sayer from Palo Alto Networks in his blog. Another example for malware on iOS is malware that came from a distributing certificates. And all provision all device certificate that gets abused, such as Mask Attack or Yspector. That means that I can create a malware and sign it with this certificate, and I can send a link to anybody to install it. But again, once Apple identifies you, it knows how to knock on your door. It has your address, it has your name. So if you think about it, the ROI on malware creation on iOS was not that high. But Apple has changed that, and we'll see how. Another example, or maybe more the previous example, what you can call a scamware or a copycat application. By abusing the app review process, I can upload a copycat application, hijacking the entire content of the presentable layer of that application. It will look the same on the App Store. User will download, will pay for that, and I got my bucks for the money, right? But in the old case, long run, Apple knows who did that, and Apple can attribute that if it chooses to. When looking at malware capabilities, okay, so we know what the risks are. What's the gain for us for creating malware? When you look at the gain, and analyzing historical malware on iOS, so you can take private API and abuse them to your extent. Install or remove additional resources on the operating system, access to the address book, access to users' calendar and meetings, extract data from its metadata from its photo stream, access microphone, hot mic plugging, GPS location, and especially pinpoint GPS location. If I know where you live, because I'm tracking you with the GPS permission, and it's pinpointing, now I know where you live, and I probably can assume what's your income level because I know which neighbor you live in, and I know where you work, and I know how much time you're spending at work because you're not moving. And that's going to cost you and backfire for you with your health insurance, right? So having that metadata is very, very efficient for causing either direct damage or collateral damage. More capabilities is de-anonymizing the user, right? Accessing private API to have a pinpoint identification of the device itself. So even if you upgrade, downgrade, or sell a device, we know where that device came from. Hijacking legitimate application resources phishing for credentials, and even polymorphism using a pre-signed framework such as Lua or JavaScript Core in order to supply remote updating of your malware capabilities. So all of that is very, very promising, but we came to a very basic understanding, which is if you create a malware, either going through an app review or not going through an app review, and Apple had found out about you or someone has tipped them, you have your identification and you go to get attributed. And all of this has changed dramatically when Apple has introduced its homebrewed certificate program. So not latest, Apple has introduced its Sign In with Apple ID program, which allows anyone to gain access to a developer certificate. Anyone can gain access to a developer certificate. Anyone can gain access to a developer certificate without supplying any identification or proper identification to Apple. All you need is an email. That's it. So this change of rules was introduced together with Xcode 7. It is called Sign In with Apple ID. And it allows anyone with a valid email gain access to a certificate that will sign code and will cause it to be installable and executable on any unjailbroken iOS device. Sounds very promising, right? Let's see how easy it is to create an anonymous or fake Apple ID. So you go into Google and create a new Gmail account. Of course, you're falsifying all the data because you don't want attribution. So you create a Mary Poppins account and you validate that. Yeah, Google might misbehave, right? And there you go. Welcome to your new Gmail. So now let's do the same with Apple, right? So you go into Apple, iCloud, or any other Apple-provided services, and create a new Apple ID with your just faked-out Gmail account. You probably can automate that, right? It's not a big deal. And once you've done that, you need to go into your fake Gmail and validate your falsify developer account on Apple, right? And that's it. You're done. Welcome. You could connect with Xcode, download your developer certificates, and start signing any code you wish on an unjailbroken iOS device. Very simple. But Apple has introduced several capabilities restriction to this program of signing with Apple IDs. Apple had declared that thou shalt not have access to Apple Pay. Thou shalt not have access to associated domains or Game Center or iCloud or VPN configuration. Those are off limits. But you want GPS pinpoint location in the background? Be my guest. You want access to health kit information, medical data information? You can have it. You want access to the user's whereabouts, its home, its security system at home, all of his thermostat, air conditioning, shaders, configuration via HomeKit? Be my guest. That doesn't concern me. So we're looking at all of these capabilities. Now we can create our own burst of malware, right? It doesn't go through Apple. We don't submit any code to go through code review. nobody will know what we have created. And Apple has helped us by lending a hand since iOS 9. Since iOS 9, Apple has changed the way that iTunes backups and iCloud backups work. Prior to iOS 9, all of your applications were bundled together with your data when performing a backup. So when you perform a backup, you had a copy of the original application sitting on your desktop and all of its content sitting along with it. And since iOS 9, Apple had removed the possibility of backing up the original application, which means if you, by some way of magic, install a malware on a device, you cannot analyze it on your desktop because you don't have access to it. You need to have a sandbox escape exploit or have a jailbreak exploit in order to gain access to that piece of code because it's on a device. It's not going to be backed up. Once it's there, it's ticked. You can either delete it or leave it. But you cannot analyze it. You don't have access to it. And looking at these playgrounds, we have the following capabilities. I can pinpoint your location whenever time I want by abusing the background pinpoint location functionality. I could gain access to your address book by approving your address book access and see all of your new connections, your contacts, emails, and more. I could go even further from copying all of your PhotoStream data and videos and try to extract sensitive information from the EXIF metadata of your photo data. One of the alleged ways that got Sean Penn so much scrutiny. Access your calendar data. And heck, I can access your health data. See what your glucose reading are, if you're having any cardiovascular problems, or any other health data that is stored on a device. And if I was an original application submitting this requirement to Apple, Apple has specifically claimed that you must provide HIPAA compliance to all of your accessing to medical records, medical data. You must follow that data model. It's not that you can get access very easy by going through Apple. So why should I? If I could just install it on your device and that's that. When you look at it from a summarization point of view, when you create a malware utilizing home root certificate, you don't go through app review or code inspection, so nobody knows what you hid inside of your code. Once the code is installed on a device, no one can identify what's the true meaning of that code because Apple has stopped backing that up to the PC or to cloud. And because you utilized home root certificate, you didn't send any identification factors to Apple, so they don't have anyone to attribute with. All they have is a falsified email account. So you don't get scrutiny. And all of this process might be looking like very tedious, but actually it can be very, very much automized. And this is Suicider, which I have presented at Black Hat Asia in the past month. It's a framework to create an evil client malware out of an original application by simply running it and connecting a device. All the automation process with Apple Cloud is done via the API of Spaceship. It's running on a Theos engine, creating a new template, and hooking up any application with Cycrypt and iSpy for evil client functionality. So automating the process, you can create any evil client that you want from any legitimate decrypted application that you have a copy of. So let's see an example. So this is a demo of running Suicider on a then non-jailbroken iOS 9.2.1, but it's still running on 9.3.2. So Suicider is available over GitHub under MI3 GitHubs, and it runs on top of Theos. So you have a new template called Suicider. You choose it, you enter a project name or whatever, and you're copying your decrypted application to be hosted into your Suicider folder. And then you run Suicider when the phone is connected via USB. Connect your phone, press enter, and have internet connectivity, because you're going to call Apple and ask for signing certificates and provisioning profile for that specific application. I'm speeding things up. So it's create the injected dylib with Cycrypt on it and iSpy on it, and it connects for Apple, asking for a provision profile for that device with that piece of malware. And now, once it downloads it, it re-signs the original application as an evil client. So now the Skype application has been injected with all of this malicious content and has the same look and feel, the same behavior plus plus of the original application. And best of all, no one with non-technical background will pick up under the profile management to look at the available profile for that specific device. It looks like a Skype, it acts like Skype, apparently it's a Skype. But it's not a real Skype, it's an evil client. It's an evil Skype or evil Facebook or evil whatever you want. And to prove that, we're connecting to that instance over Cycrypt remote shell. So connecting over it, gaining access to any internal memory object, in this case UI label, and directly manipulating it to your needs, which is, in this case, just editing a UI label, but the same thing you can do with any other memory object runtime on that device. Decryption keys, chat history, passcodes, VPN credentials, whatever you want, MDM policies, and more. Okay, so now Skype is in control of Cycrypt, right? The attacker. Very easy. I didn't have to write any code. Just click, next, and I have an evil client that looks the same on the application. One Skype, two Skypes, three Skypes. Which one is the correct one? The user may never know. So when looking at this attack vector, one might ask, okay, so wait, in order to actually get the device infected, you have to have access to the device, right? It could be passcode protected or not passcode protected, but you have to have physical access to the device. You cannot install this via telepathy, right? It's not remote installation. You have to have access to the device. That's correct. Think about spouse, ex-wife, ex-girlfriend, or ex-boyfriend, ex-husband, a colleague, or even better, think about all of these iPhone stores. So you drop the phone on the floor, now the touch screen is broken. Have you ever heard of someone who's doing a full hardware reset on an iOS device before it goes through iPhone repair? Only the fanatics, right? So now each and every one of these stores, or particularly anybody with access to your code, to your device, have the possibility to run malicious code on it, because Apple has changed the rules. Anybody with an email can have signing certificates, even these guys at the phone repair shop, or your colleagues, or your friend, or your ex, or whatever. Utilizing all of these capabilities that Apple has left behind, available to use, backgrounding, mode, GPS, contacts. You just need to install and then approve the one-time acceptance for that privacy information. So that's a big idea, right? But let's try to take it to the next level. Can I use this to gain access to these rich content that was laying around, right? Can I use Skype to take over of the Skype messages? Can I use an evil WhatsApp to gain access to the evil WhatsApp messages? Can I use this evil password manager to gain access to your passwords without knowing the password, or by allowing me to modify its behavior? Can my evil client take ownership of the original application sandbox? Well, that is sandjacking. So, sandjacking, in fact, is allowing an evil client to exploit the naive of the operating system by allowing him to gain access to the original content that the original application created and saved on the device. And when you're looking at a sample example, we're going back to the FBI versus Apple, or versus our encrypted application. So now we have an encrypted application. We have someone who wants to extract that application. The application has some kind of a brute force mitigation implemented in order to wipe all the data once 5 or 3 or 2 consecutive failed passcodes were entered. And what you would like to do is not pay $1.2 million in order for creating a brute force possibility, but utilizing an evil client to tweak the application behavior and gain access to the user content. So all of these security containers sits on the phone, and we would like to use our evil client with patch functionality to take over that original content by using sandjacking. So sandjacking on iOS 8.3 is very easy, right? Because Apple didn't implement anything to mitigate against. If you have the same bundle ID with the hyphen, Apple will treat your evil client as the original application. You just install it and bam, you have access. So, okay, 8.3 is pretty outdated. What happened after 8.3? Well, Apple had figured out that this is a big vulnerability, because anybody who has access to your phone can just write down malware to take over all of your original application. So it implemented a fix that says you have a mismatch application identifier entitlement. Your upgrader application, the evil client application, doesn't have the same bundle ID as the original application, so I won't install it. It won't upgrade. And that fixed everything for 8.3. That was what Apple had believed. But apparently, Apple has patched only the front door, but the back door is left wide open. Apple had forgotten to patch the vulnerability on the restore process. So, a la sandjacking on any iOS version can be done very easily by backing up the device with all of the rich content that the application holds, deleting the original application, installing the evil client, which now will be acceptable because it's not upgrading anything, and then performing a restore process. And by performing the restore process, all of the rich content of that specific application is being served to our evil client. So here's a demo. Let's look at one specific application. In this case, a passcode manager container. So we set up the stage. We download this password manager. It's installed on a device. We set a passcode. And as you can see, there is a brute force mitigation. If you will try too many attempts and it consecutive fail, it's going to wipe all of the data and you gain nothing. Sounds familiar, right? But in this case, not a specific device. You can have several of these on the same device. It's an application container, encrypted. So now we have this application. Let's try and run Suicider on it. And try to run it on an upgrade process, right? So you run Suicider on the application. We create an evil client. The original application is still installed, which will try to install the application and upgrade the original application with the evil client, but as we said, Apple had patched this vulnerability. It won't allow install to upgrade an evil client with the original application installed already. So in this case, what we can do is take the backdoor and use a backup process and a restore process after we wiped out that application. And by restoring the original content on top of our evil client, iOS had left the door open for it to gain access. So now our evil client have access to the original generated user content. It has access to its GPS awareness, it has access to all of this capabilities that we talked before, but also has access to all of his personal and private, intimate data. But the data is encrypted, right? So what we can do is mitigate against the brute force mitigation, right? Circumvent the brute force mitigation by removing that penalty. And this specific functionality is we can ask the database, the internal application using Cycrypt, and it running is the password equals this string without going through the penalty process, the penalty function, right? So if the penalty function is not called, that's good. So we have a Cycrypt shell side-loaded with various functionality on the side of the security container application, and we want to brute force all of this effort, right? So what's easier to do than to pipe out a dictionary with passwords straight through shell, right? Take Metasploit dictionary, Unix password, and run it over, fetch it over to Cycrypt, and consecutive asking is the password equal. Brute forcing without going through the penalty. And we had only 5 consecutive failed attempts on the original application, but on the evil client we can do whatever we want. So I'll speed this a bit because I chose the last password, so we have enough demo time. And you can see for each and every one of these passwords, the answer is false, right? 0 is false, 1 is true in this case. So this is brute forcing, low budget brute forcing. Doesn't require $1.2 million, although I would like the bonus. But yeah, but eventually we find out that the password is Raspberry. I hate Raspberry. So typing in Raspberry on the security container application, and welcome attacker. You now have access to the previous installed application security content that was encrypted and was mitigated with a high cryptographic engine, PBKDF2 or whatever. So by mix and matching these capabilities and the sandjacking, one can truly profit from an iOS malware. And this vulnerability was disclosed responsibly to Apple on January, late January, Apple had responded, and their latest update was that they are working on a fix, and they got it reproduced. But the Sandjacker tool that was about to release in this presentation will have to wait until that patch is implemented in order for not allowing sensitive content being exploited by these tools. So hook up with the website mi3security.com, and once the fix is implemented, we release a Sandjacker that will automate this process. And now it's time for a bit Q&A if you have some questions.
So you mentioned being able to do this on a device even if you don't have the passcode. Wouldn't the user still get like the dialogue that they must trust this developer?
He must have the passcode, or
Okay.
the device doesn't have a passcode implemented, right? If you give your phone to a repair shop, or your girlfriend, or someone intimate, a coworker, someone who has access, it doesn't require any more than 5 seconds to install an evil client. An unaware user will not selfly go into preferences, and then settings, and then device management profiles. That Skype is provisioned by a different, it's not an App Store application. That's a whole total change of mind that he wouldn't expect. But yes, you must have the passcode for that device. So repair shop is a very, very common phenomenon to have your device and the passcode together, or someone intimate with the device, or share device. Like there's a lot of people running on, especially price equipment on inside of startup. You have an iPad Pro, which is one for the team, and you have different accounts on it, and users usually rely on the login screen to protect their privacy, or a passcode screen to protect their privacy, but that can be circumvented. Think about exploiting this by an evil employee. So let's say I'm inside of a corporate and I have this MDM that's blocking me from doing all of the things I want to do, exfiltrate data. Well, I could evil client the protective storage application and exfiltrate data without jailbreaking the device that caused a lot of damage or a lot of noise on network, without nobody knowing where the data has been exfiltrated.
Okay, thank you.
Sure. More questions?
You said that WhatsApp is storing messages unencrypted on the device.
You got that, huh?
Yeah.
Yeah.
So an
I
attacker,
know only for the latest version, right? So
so it's only encrypted on the network or on
it's
on their
okay.
servers.
So it's not encrypted on a device, which means if you haven't enforced encryption of your iTunes backup or your iCloud backup, it won't be encrypted. That means anybody who has access. If I have malware on your installed on your PC, then you're gone, because I have the certificates to gain access to your device over Wi-Fi. If you enable Wi-Fi sync, I could initiate a backup whenever I want with these certificates. I could back up the content of the WhatsApp, and I can harvest them and send them away. They're not encrypted. If you have implemented an encrypted storage, or you passed on the iTunes, there's a possibility of backup and encrypt my backup, or some MDM corporation enforce encrypted backup, then this backup will be encrypted. But that can be brute force, offline, right? More questions? Yes.
Yes, hi. I have a question. So in your demo, you didn't explain how the passcode was secured. So I was wondering, since you talked about backing up the containers, the application containers, you didn't talk at all about the keychain. Because if the application is well implemented, is correctly implemented, the passcode will not be in the container, the application container, but in the keychain. And for that, you have no way of extracting the keychain information if only if the device is jailbroken, right?
That's an excellent question. And the answer is two scenarios. A, what is the notification that application gets when it gets deleted from the device? What's the notification? Do we have any? Do Apple has any published API that application gets a notification like application is going to be deleted? Oh, okay, I'll stop there. I'll go wipe out the keychain. But there is no mechanism like this available. So when application is being deleted, all of the keychain storage is left inside, right? And most of the keychain data is being backed up with the backup.
Yeah.
You have to specifically mark any data, file system on the same side, to not back up or it will be backed up. So when you look at mitigation, if you're a developer, you must mark file system and an attribute do not back up, and keychain mark this device only. This device only tells the iTunes backup process, listen, this is a security container, encrypted or protected. I don't want it to be duplicated to iTunes, to iCloud, any backup going to create another backup. Because if you hadn't done that, then you have a security container with an encrypted secret or a clear text secret, God forbid, who's getting duplicated and duplicated and duplicated each time the user performs a backup, or automatically because you have iTunes backup all the time, to the cloud, to anywhere. So you have multiple places, multiple locations of that secret. Ergo, it won't be a secret anymore.
Yeah, so assuming that the keychain is left untouched once you remove the application, when you inject your compromised application, assuming that you inject it with the same UID, right? But you will sign this application with your own certificate.
Right.
So do you still have access to the keychain information?
Only to shared keychain, right? I won't to
correct.
keychain group. I won't be able to overwrite the original storage, right? That is correct.
So that's a good mitigation, actually. that
Yes,
Apple
good
implemented.
mitigation. That's good. Good mitigation are using app groups. Well, app groups are specific file system containers that are shared between same vendor, same developer. Sorry, not same vendor, but same developer bundle identification. But because my malicious certificates are not one part of these developer certificates, they won't match. So if you want to mitigate against evil client, one safe location is going to store your data in an app groups container, which WhatsApp does. Or you want to hold your secret IVs or encrypted hashed inside of your keychain, and that keychain is not shared by that app group, so you won't have access. But anything else relying on iOS default security will get you exploited. Any more questions? Yeah.
Hi. Considering that the way of getting into the phone would be via signed application, and the one you explained was self-registering, there is another way of stealing the certificate of the legit signer,
Of
correct?
course,
As a
of
transmission happened
Of
recently.
course.
So,
So-
would you know what would be the ratio of malware that's been seen so far? Maybe how more often would it be with this? I'm aware that it's much harder to steal the certificates right from the legit developer.
Right. You need.
But-
Well, although some
Do
developers.
you know any
just-
numbers on it, maybe?
No, I don't have statistics. But yes, it's more trickier, or it's more difficult to steal developer certificate.
It would be more rewarding as well.
Right. More rewarding, I don't know. Depends on what your profile of attack. Are you trying to distribute an attack against various clients, or you just need that high profile one, your ex? I don't want to spy on old people. I just want to spy on my ex. Or I just want to spy on my kid. I don't want to let him know what's going on. I don't want to ask him for his passcode or asking for whatever. Have that daddy monitors you with the big eye on the icons. It's a pretty downer for the kid. So I want to monitor his Facebook communication, see if someone is abusing him. I could take this all into protective stage, right? But the forms are the same, the tools are the same, and the power is the same. It's the agenda behind the power that will lead into the exploit or the usage, good usage of this functionality. Any more questions? Yes, in back.
I was just wondering, actually, like, obviously,
Well, because I have total control on the application content, one of the key components in that application is the info plist, who enlists this application version. So let's say I installed malicious Facebook on your account, and Facebook currently is, I don't know, 7.9 dot something. I'm going to boost your version to be version 1009. Good luck with that, right? No updates for a decade or so. Depends on the Facebook lifecycle, right? So, any more questions, guys? Yes.
So you mentioned that WhatsApp doesn't encrypt things locally. Does Signal? Do you know offhand?
That's a good question.
I think it does. I think it stores encrypted locally because you try and export the data, you have to export it plain text, and one default is going to go to plain text.
It's encrypted locally. I tried to use Signal for one of these demos, but it was too damn tedious to backtrack the decryption and presentation. Because when you think about it, when you have the evil client and the data is decrypted, you have your data decrypted, and you can do with whatever you want with it because it's evil client. It's running on your ground, right? Think about all of these secure chats. Nobody can take a screenshot of that application because it will send a dismissing alert to anybody on the group saying this user just used a screenshot and you get shamed. So if it's an evil client and you have the credentials, you can do whatever you want. You have using WhatsApp, right? Or using evil client using with Signal. One of the most key component the application vendors missing are binary protections, because injecting a new dylib into the macro file changes a lot of things, right? But it mostly of getting unnoticed. Lack of binary protection and lack of protecting and validating application is really something that needs to be considered. But when looking at it on the long run, everything is running on my device, on my terms, on my ground. So everything can be circumvented. It depends if it be easy or it be difficult. And I will switch to a different application. Yes?
Do you know if you modify, for example, a Signal application, would it modify the fingerprint of the user? Do you know or do you not?
That's a good question. Why would it modify it?
Because if the any of the application, I don't know how it generates the fingerprint, to be honest.
If you would like to think of a secure way of doing it, will be to distribute different keys, having a PBKDF using all of these set of keys, having the bundle ID, installation type, file path, iStore recipient you can get from a public API. It's not private API, and using that to create one part of the key, getting backwards back server. On a successful login, get your backward part of the key and then create in the decryption key, you can decrypt messages. That's chaining things together, and that's the secured way of doing it, probably. Any more questions? Okay, so the last, yes?
So when you reset the application, the signing certificate changes, right?
Of course, because I'm signing it with my spoofed.
So can't they like just implement some security around the signing certificate, like for giving access to the key store, for example? They can like match the signing certificate for which it granted the key store access and then maybe denied for everything else.
Well, Apple can do that. Apple can export a lot of private concerning APIs to the user, but currently it's not that of aware. Evil clients are not that aware. Sign in with Apple ID is not that got it awarenesses. The exploitability is very high, because up until now, in order to create a malware, you had to have a developer a certificate, you had to go to identification with Apple, you had to have a lot of hoo-ha, which get you attributed if something bad happens. But all of that changed when Apple changed the rules. Yes?
Before iOS 8.3 it worked with a different certificate, and after the statement, what were they checking?
The bundle ID.
Bundle ID.
Yes, the bundle ID. Because even if you are the developer and you want to create a new application with the same bundle ID, it won't let you. So it's occupied already. You have to use what you have. So bundle ID is a unique constraint on Apple backends. So in order to create a follow Facebook, I have to use the column Facebook, Facebook dash, I don't know, 75, and that's it, right? Because the dash is the application extension. They treat it the same as the original application. And that's what Suicider does. If you want to look for, any more questions?
So for any app which checks the integrity, this won't work, right?
Any apps that what?
Which checks for their integrity, because we are re-signing it and the integrity is lost, right?
No, it won't help because they have to implement encryption that is based on a key that is based with a PBKDF that is an output of some
Let's say I'm
protection, right?
let's say I'm Facebook.
Yeah.
I am checking the integrity of my app before it runs. I can self-check my app for integrity, right?
I can patch it.
Yeah, but you have to statically patch it for every single app, right?
Yeah, of course. I can patch it. Like you patch jailbreak detection, like you patch anything else. It has to be part of a decryption process because if it's just a yes or no question, you patch it. You patch it with a nope, you patch it with a branch, you patch it with a cycrypt script. It's very easy to patch. It has to be linked internally with cryptography. That's one of the OS top 10 mobile is broken cryptography when the passcode screen is just a facade. It's not doing anything. Yes, please.
So Stefan Esser's app had sort of jailbreak detection in it, and there was sort of various people throwing claims around. Is there any reliable way to do jailbreak detection that can't be patched, or I mean, is there any way you can pass syscalls directly to the kernel, or?
The answer is no, but it depends. And I'll explain. Whatever is running has passed your research, has passed your time with it. You spend intimate time with that application. So as time passes, you gain more knowledge, and more knowledge, you gain more power, right? So the only way for you to protect against it would be to break down the data, the sensitive data, and have it stored either server-side or have it encrypted very harshly, although encryption can be decrypted, with a passcode that you have one part of it in the server-side. So if we would like to mitigate brute forcing, let's be doing it on the server side, right? One fail login, second fail login, third fail login. I have the control, right? The vendor has the control. If it's self-contained on the application, then it's breakable as a function of time and effort. Any more questions, guys?
Any more questions?
Okay, so this is the Black Hat Asia talk I gave on the evil clients, homebrew certificates. The videos are still not there, so you might go through the slides. It's much more details on evil clients. Cloud Sayo from Palo Alto Networks is an excellent security researcher, and he's a very good source for everything that goes on iOS and malware. I thank you very much for joining my sandjacking talk. My name is Chilik Tamir, and I work for MI3 Security. Thank you very much.
Thank you, Chilik.
Thank you.